Welcome to one and all. Today we are going to see how to solve the assignment model or assignment problems in quantitative techniques in management. As we already know how to solve the assignment problem by using the Hungarian methods and PRET techniques uh, by applying the steps for it, and as we know or solve the special cases regarding the unbalanced type of problems in assignment and the maximization problems in assignments. Today we are going to see the third type or third special cases which are involved in assignment problems or assignment model is known as your multiple optimum solutions. For it, after making the assignments uh, to a single unmarked zeros in all possible rows and columns, is found that two or more rows or columns still containing zeros, so then unmarked zeros. For it, the problem has to multiple optimum solutions, then go get the alternate solutions. For it, first select the rows or columns containing the maximum number of unmarked zeros after making the assignment to the single unmarked zeros. Then select one of these unmarked zeros and mark it with a square. Cancel all the other zeros in its rows as well as in columns and proceed further in usual manner to make the other assignments, and repeat this procedure by making the assignments to each of the zeros in the rows or columns, selecting the above step 1 separately to get the alternate solutions. And all these alternate solutions gives the same optimum values. So how we are going to solve these multiple optimum solutions in assignment problems? Let's check it out. Write down these problem. Solve the following problem of assigning 4 computer programmer to 4 application programs where the estimated computer time in minutes required by each of them to develop the programs is given. So here the programs as well as the programmers are given to us with respect to the time in hours, times in minutes. So write down in the next table all the values. So apply the Hungarian methods or flood techniques. As we all of you know, the step 1 is our row subtraction, in which we need to identify the minimum value in each row and subtract these minimum values in that particular row values. So see, for program A, the minimum value is 80, so 120 minus 80, 40, then 20, 80 minus 80, 0, 90 minus 80, 10. So next program B, row B, minimum value is 70, so 80 minus 70, 10, 90 minus 70, 20, 110 minus 70, 40, 70 minus 70, 0. Next program C, 110 minus 100 is comes 10, then 140 minus 140, 120 minus 120, 100 and minus 100 is 0. For D, minimum is 80, 90 minus 80, 10, 90 minus 80, 10, 80 minus 80, 0, 90 minus 80 again, 10. So here we completed our step number 1, then move on to step number 2, that is our column subtraction, in which we need to identify the minimum value in each column and subtract this minimum value from with respect to that particular column values. So programmer A, for column 1 minimum value is 10, so 40 minus 10 values comes 30, then again 0, 10 minus 10 0, then again 10 minus 10 0. So programmer 2, column 2, the minimum values is 10, so 20 minus 10 10, 20 minus 10 10, 40 minus 10 30, 10 minus 10 0. The next programmer 3, the minimum value is 0, so again all values remains as it is. So next again programmer 4, again the minimum values is 0 in that respect to column 4, so all values remains as it is. So our next step is step number 3, draw the lines which covers the maximum number of zeros. So by inspections you can identify the row D, program D having the maximum number of zeros. So draw the horizontal lines which covers the maximum number of zeros. Then next again by inspections you can identify it row C having the maximum number of zeros, or you can say that column 1 and as well as the column 4 having the maximum number of zeros. So if you want to draw the vertical lines for both the columns you can draw it, otherwise if you want to draw horizontal lines you can draw it. Both way are the correct. Then next B again having the maximum number of zeros, so draw the horizontal lines. One single zeros are left, column row A. So draw the horizontal lines. So write down the next step. The number of lines is equal to the number of rows and columns. So here the number of lines is equal to 4 is equal to 4. Columns and rows are 4. Therefore, the solution is optimum. So step number 4, make the assignments as follows. Program A you are going to assign to programmer 3 and cancel out the successive zeros with respect to column wise and row wise. For program B, you can assign to programmer A and cancel out the other successive zeros with respect to row wise and column wise. Then program C, assign to programmer 4, cancel out the other successive zeros if it is present, but here already we cancel it out. Then program D, you are going to assign to programmer 2. So here we completed our assignments. So write down in the next table the assignments. Program A you are going to assign to programmer 3 with the original values 80. Program B to 1 with the original values of 80. Program C with the original values 100. Program D to programmer 2 with the original values 90, and the summation of this programmer in minutes is 350 minutes. Or you can assign in another way. So again, programmer A you can assign to programmer 3, cancel out the other zeros which are represented with respect to column wise as well as row wise. Then program B, here you can assign to programmer 4 and cancel out the other successive zeros which are represented in row wise as well as column wise. Then next program C, you can assign to programmer 1 and cancel out the other successive zeros, and programmer D to programmer 2. Then make assignments in next table. Program A you are going to assign to programmer 3 with the values is 80. Program B you are going to assign to programmer 4 with the values is 70. Program C to programmer A with the values 110. Programmer D to programmer 2 with the values is 90, and summation of these is 350. I hope all of you better understand how to solve the multiple assignment type of problem. So next we are going to move on to next special cases is known as prohibited assignment problem. So here in these prohibited assignment problems, these are indicated by putting a dash or cross at the prohibited positions to solve the problems. For a minimizations or maximization problems, assume infinity cost for the prohibited positions and proceed further as usual. Note they automatically makes these cells unit for inclusions in the optimum solutions. So write down this problem. Consider a problem of assigning 4 clerks to 4 tasks. The times in hours required to complete the task are given. Clerk 2 cannot be assigned to task A and clerk 3 cannot be assigned to task B. Find the optimum assignment schedule. So here they restricted to assignment of clerk 2 to task A and clerk 3 to task B. So write down these tables. So it is a minimization problems where the assignments to 2A and 3 to B are prohibited. Hence, assume infinity time for 2 to A and 3 to B and solve the further using by the Hungarian methods. So put the infinity in front of the dash values. So write down the table once again and solve by applying the Hungarian methods. So remember our first step is always the row subtraction. So find out the minimum value in each row. So in first row, clerk 1 the minimum value is 4, clerk 2 the minimum value is again 4, clerk 3 row 3 minimum value is having 3 minimum, and clerk 4 the minimum value is 2. So subtract this minimum value from with respect to the row values. So 4 minus 4 0, 7 minus 4 3, 8 minus 4 4, 6 minus 4 2. Next row, clerk 2 minimum is 4, infinity minus 4 infinity, 8 minus 4 4, 7 minus 4 3, 4 minus 4 0. Next for 3 row 3 clerk 3 minimum is 3, so 3 minus 3 0, infinity minus 3 infinity minus 3 5, sorry 8 minus 3 5, and 3 minus 3 0. Then next clerk 4, so minimum is 2, 6 minus 2 4, 6 minus 2 4, 4 minus 2 2, 2 minus 2 0. So always remember, note infinity minus any values, it always comes the infinity. So here infinity minus 4 is always infinity. So next, step 2, column subtraction. So identify the minimum value in each column. So column A having minimum value is 0, column B minimum value is 3, column C minimum value is 2, and column D is minimum value is 0. So subtract this minimum value with respect to that particular column values. So for first A, the minimum value is 0, so all values remains as it is. Next, column B, the minimum is 3. So 3 minus 3 is 0, 4 minus 3 1, infinity minus 3 infinity, 4 minus 3 is 1. So next, task C, 4 minus 2 2, 3 minus 2 1, 5 minus 2 3, 2 minus 2 0. For D, again the minimum value is 0, so all values remains as it is. So here we completed our step number 2. So move on to step number 3. Draw the lines which covers the maximum number of zeros. So here by visual inspections you can clearly identify it where the maximum number of zeros are lies. So in a D column having the maximum number of zeros, so draw the vertical lines which covers the maximum number of zeros. So next move on to again check it out where the maximum number of zeros are lies. The maximum number of zeros are lies to column A. So draw the vertical lines which covers the maximum number of zeros. Again then identified it where the maximum number of zeros are lies. If you see our observations, you clearly mentioned that the column B and C having single zeros are lies over there. So if you want to draw the vertical lines for it, you can draw it. If you want to draw the horizontal lines either in a row wise for clerk A, you can draw it. Both way are the correct. So here the clerk 1 having the single zeros, you can draw the horizontal lines which covers that particular zeros. Then for 4, clerk 4 having the single zeros, draw the horizontal lines which covers that particular zeros. So your number of lines is equal to your number of rows and columns. So 4 is equal to 4. Therefore, solution is optimal. So make assignments. Step number 4. For clerk A, you are going to assign to task B and cancel out the other successive zeros which are represented in particular row wise as well as the column wise. But in column wise, there is no other zeros, so leave it. Then clerk 2. Then clerk 2, you are going to assign to task D and cancel out the other successive zeros which are present in column wise as well as in row wise. And clerk 3 represent to assign to task A and cancel out the other successive zeros in row wise and in column wise. In all the other zeros are already cancelled out. Then next clerk 4 assign to task C. Here we completed our assignment. So make a table. So clerk 1 you are going to assign to task B. The values is 7 from the original matrix table. Clerk 2 you are going to assign task D with the original values 4. Clerk 3 to task A with the original values 3 and clerk 4 to task C with the original values 4. So summation of these 4 values is 18 is your last answers. So in this way you can solve the prohibited type of assignment problem in assignment model. Thank you. I hope all of you are understand all these steps and how to solve these special cases in assignment problem. Thank you.